This is the free radical substitution reaction. The most probable question which we come across in this, we will discuss under this heading, a simple photochemical reaction. The reactions which takes place in sunlight, that's going to be known as your photochemical reactions, children. In terms of kinetics, it's going to be a zero order reaction also. Absolutely, we can answer that. We have done two questions here. But coming to this free radical mechanism, almost all, any photochemical reaction is going to take place in the manner of free radicals. So that here, what is the possible question, children? When we have taken methane and chlorine, the first step which we are going to get methyl chloride and methylene chloride, chloroform CCl4, carbon tetrachloride. Its another commercial name is called pyrene. Of course, in halogen compounds also we will discuss. It's the very good fire extinguisher of the gases produced by burning of natural gas. It's fire extinguisher. So, children, the question is going to be like this here. The possible question is going to be, they'll ask you like this. For example, Baba, now they have given like this CH4. And or else we will take Cl2, sunlight, Cl free radical. Due to homolytic cleavage, you are getting whatever that homolytic means, equal cleavage of bond. That's going to give us free radicals. This is called formation of free radicals is initiation step. Initiation of the step. And next one, whatever is called here CH3H. This is also in presence of sunlight. CH3 free radical, H free radical. After that, children, when we are going to see this now, the question is related with this. What's the possible question? That's nothing but, so this is called initiation step. Propagation. What is going to be propagation? The propagation is that we should find the free radicals on either ends, CH3 free radical and also ClCl in presence of this. Then you are going to get CH3Cl plus chlorine free radical. That also we are going to get here, right, children? And this is the free radical. There should be free radicals on either sides. That's going to be known as your propagation step. When you have taken chlorine free radical, the methane gas is taken. Now, in presence of sunlight and due to photon effect, and that's going to be give us what's called here. What does it give, children? It may have the chance of HCl also. Like that, it goes to give us what is called here hydrogen free radical also. That's going to be HCl plus CH3 free radical. This is the possibility. This step is going to be considered as propagation. When the free radicals are on the reactant side, just easy way to identify. On reactant side as well as product side, that's called propagation. Termination, Baba. What's known as termination means the free radicals combines to give us a product like HCl and similarly Cl free radical, Cl free radical, Cl2. Like that, CH3 free radical and Cl free radical. All are photochemical reactions. Baba here, CH3Cl. So like this, termination, interaction of free radicals to give you a product. That's called, that you can see the free radicals on only one and that's on reactant side, non left side. Propagation, the free radicals might be on either side. Can be written in another way, no need. Just I'd like to make you to know the free radicals are present on either sides of the chemical reaction. That's going to be considered as what you say here, the propagation step, and finally it's going to be termination step. So what we have done is the most possible questions here. This is going to be taken in this way. When you have taken, children, this one, methane and chlorine, we will do the next question. The most focused question is related with propagation. That's going to be important. And what is the mu of these compounds, whatever is called here, the mu of this one is going to be, which one has highest mu value? CCl4 is 0, mu is equals to 0, means it's due to tetrahedron symmetry. After that CH3, whatever that, after that CHCl3, because the bond movement is towards chlorine. This is third possible question here. The bond movement is towards this one, and hydrogen. This is also this side. After that, children, next one, after that CH2Cl2, like that, it's Cl, Cl, hydrogen and hydrogen. See, it's almost all balancing, but coming to this methyl chloride is going to have highest, methyl chloride is going to be highest one, children. Then whenever it is going to be highest one, no, now that means, let us go through this. The bond, the dipole is going to be towards the central atom. The charge is more polarized on central atom. Hence, it's going to have higher value. The mu increasing order is this. It's going to be mu increasing order is this. So, as a dipole moment question comes, one more question also we will do it, not required. So that it's having tetrahedron symmetry, so that mu is equals to 0. But mu in these cases are not equals to 0 in all these three cases. But highest mu value is associated with CH3Cl. But one more thing I'd like to tell you, children. Everybody known mu of NF3 is less than that of mu of NH3. Both are having nitrogens, no? Nitrogen, fluorine is going to be like this. The bond movement is going to be towards fluorine. It's going to be, it's a vector sum, no? Here. And coming to this, sir, why it is more? Both nitrogens are going to be same as in the central atom. The second question I am doing, children. Now, this is the lone pair. This is going to be towards nitrogen due to more electronegativity. That's why it's away from, the bond moments are away from the central atom. Hence, its mu value is lesser than that of ammonia. It's to second question also. As per NCERT, I'd like to do one more possible question also. NCERT, as per NCERT, mu of H2O is greater than mu of HF, of course. Why? This means it based on bond movements they have given in the NCERT. In fact, HF has to be more. So this is one of the steps which we have done, Baba, here. Now, coming to this, I'd like to finish with this with a simple possible question. I told you free radical substitution. The another question, which method is not useful to prepare methane gas? The methane gas, which method is not useful to prepare methane gas? That's going to be the marsh gas, where it evolves in the marshy places. What you can write, Baba? Wood's reaction, everybody can write. And what is second one? Kolbe's, that's going to be whatever is called here, Kolbe's reaction, because they prepare double the number of alkanes. That's all going to be prepared, what do you say here? Double the number of alkanes here. So, mostly this is going to be the two cases which I have shown, and some more also we will see. The preferable question is going to be given from this, whatever is called here. The methane gas is concerned, cannot be prepared by these two methods. Now, let's go through this. Another one also there, children. So, that's next part which we are going to do in this connection. What's that which we are going to do means Kolbe electrolysis. What's that Kolbe electrolysis? Let's go through this, children. Kolbe electrolysis is concerned, when you are doing the Kolbe electrolysis, very, very prominent questions which you come across here. What's that prominent questions which we come across here means? Now, let me discuss with you, children. Now, what's the Kolbe's possible question? The Kolbe's possible questions are going to be Kolbe's reaction. It's used to prepare higher alkanes from fatty acids like CH3COONA. If you have taken CH3COONA, 2 moles sodium acetate is subjected to what you say here, electrolysis process. Electrolysis process, when 2 molecules or 2 moles are taken, this free radical combines with this, and whatever that is going to be given here in this way. So, electrolysis, what are the anodic products and what are the cathodic products also we will see here, children. Anodic products as well as what you say here, cathodic products. In presence of electrolysis in the hydrogen gas is concerned, in presence of water is concerned. Anodic products, what are the anodic products? Ethane. How much you will get? 1 mole. If you have taken 2 moles, 1 mole and 1 mole, and 1 mole of ethane gas is obtained, and 2 moles of carbon dioxide evolved. If you are questioned in NTP conditions, means the volume is 2 into 22.4 liters, children, right? So it's going to be cathodic products are concerned. One are going to be 2 NaOH and it liberates hydrogen gas. Sir, where from this hydrogen and OH? Because electrolysis carried out in whatever is called here in aqueous media to undergo fast electrolysis. This is absolutely called, is based on free radical mechanism, mostly not required, children. At the end I will do that questions also, but this is not the juncture to do, because some questions are preferred in JEE mains related with this mechanism part also. The anodic products are going to be this, 1 mole of ethane and 2 moles of carbon dioxide. This is whatever is called here 2 moles of sodium hydroxide, and next one is called 1 mole of hydrogen gas. That's going to be 22.4 liters if you are considered the simple NTP conditions are concerned. Like this, children, we can do so many examples also. The basic example I have shown you based on this Kolbe electrolysis. Merely we can consider possible question. 1 mole is taken, 2 moles taken, 1 mole of ethane, 2 moles of this one, 1 mole of hydrogen gas. If only 1 mole of sodium acetate or potassium acetate is taken, then you are going to get half mole of this one, ethane, and 1 mole of carbon dioxide and half mole of hydrogen. That's related with stoichiometric part question here. Followed or not? If you have taken 1 and 1, you are getting 1 mole. If you have taken only 1 mole, you are getting half mole. This is also half mole, this is 1 mole. Okay. Now, children, if you have done with this, when you have taken this, no, what's called here CH2COO minus K plus. Example number 2, I am doing this, Baba. CH2COO minus K plus. Potassium succinate is the compound. Potassium succinate is the compound. If I have taken potassium succinate as the compound, 1 mole of potassium succinate is subjected to aqueous media. E-lysis means electrolysis. Here you are getting, children. That's free radical mechanism only. Ethylene gas at anode and also 2 moles of carbon dioxide at anode. Sir, what are the cathodic products? In general, it's going to be base. 2 KOH and 1 mole of hydrogen is evolved. Whatever the OH and hydrogen evolved are going to coming from the aqueous media. So, when you are subjected to electrolysis, this is potassium succinate, or example number 3 I am taking, children. It's we are taking potassium maleate or fumarate. Potassium maleate or fumarate we are taking, subjected to E-lysis in aqueous media. Children, once again, it's a free radical mechanism. Then you are going to get here acetylene acetylene, and 2 moles of carbon dioxide. And also these are the anodic products, Baba. And coming to this, cathodic products are going to be here. One of the best question which we are going to do, 2 KOH and 1 mole of hydrogen. This is about Kolbe's 3 examples which we have done. We can do with thalamides and all those things also. Not required, children. Just a brief basic questions which we have done. But this is most significant reaction here. So, thank you, children. This is also nothing but a free radical mechanism. Once again, I'd like to go for this another session.